Okay, welcome to SEMA 2025. Today we're going to talk about the importance of 3D dimensional computerized measuring. I am Anton Verwist from ICAR. I have been a structural technician for over 25 years. Today I have with me Ruben Castorina from Rotary Solutions, also known as Chief. So he is going to give us a presentation today, and we'll see what he has to say.
Thank you, Anton. Do I need? No. Oh, there we go. Good afternoon, everyone. Well, today we'll be talking about the importance of three-dimensional computerized measuring, limitations of point-to-point measuring, measuring suspension components and mounted locations for suspension analysis, measuring ADAS mounted locations and areas, and understanding tolerances. First thing is, we're going to talk about what's the importance of three-dimensional computerized measuring, creating a center-based reference for with proper tolerances, measuring a minimum of 8 control points, and then continuing measuring until no damage is found. Well, today's vehicles have evolved and changed so much in just the past 10 years with new materials construct, electronic suspension, ADAS, to name a few. It's very important that we put the vehicle back to its correct dimensions because other systems rely on them for this functionality, like suspension, drivetrain, transmission, and ADAS.
So I just want to comment about, like you say, the importance of the three-dimensional measuring. You know, car tolerances have gotten a lot smaller over the years. We don't have that room to play with them anymore. Some cars are down to 1 millimeter. That can't be done using a tram bar or something like that. So I'm a firm believer that three-dimensional measuring is the only way to go when you're changing structural parts or checking the structure of the car.
Exactly, and that's why it's important to have a three-dimensional measuring system because you're able to verify to make sure that vehicle structure is put back to that correct vehicle dimensions. And the thing is, there are a lot of different kind of measuring systems or measuring types of systems out there, like tram gauges, measuring tape, self-centering gauges, but one thing, computerized measuring systems. And the thing is, they all have their advantages and disadvantages. But one thing about the advantages of a 3D computerized measuring system is that you can monitor height, width, and length all at the same time, plus you can get a printout of your pre- and post repairs. But above all, you can also monitor the movement of your length, width, and height when you're repairing the vehicle. The thing is, when you measure a vehicle, all measurement starts from the center section. So having a leveled, anchored vehicle will give you the most accurate measurements throughout the whole measuring process.
So I'm going to touch base on that. You talked about measuring the center section. Starting out, it's very important when we create that original measurement how accurate they are, and we can't go forward unless we have a good center base. So I'm sure we'll talk about that a little more as we go and the importance of that. But I always say that setting up your base to the measuring system is like building the foundation for your house. If you don't have a good foundation, your measurements are not going to be accurate.
And that's exactly true. Having a great accurate base is going to be very critical because if the base is not correct, the further you go away from the base, the more incorrect measurements or misalignments are going to show on the vehicle.
Yeah, so I was also an instructor for 18 years at the college, and a lot of my students, once they go into a shop, they would call me up and say they're having problems getting something right, and the first thing I would always ask is, how does your base look? That tolerances on the base mean a lot. We also have to pay attention to the arrows, minus 3 millimeters one way and plus 3 millimeters one way is actually 6 millimeters, and that's one of the things that techs really need to pay attention to is, once again, having that base within a certain amount of millimeters.
Correct. And when you start measuring the base, you want to use 4 undamaged control points when possible. And I know that sometimes there might be a scenario where you do have damage to the center section. So using 3 good undamaged base reference points will still be will still be useful in that scenario. But either case, you got to make sure whatever control points you're using in the center are within tolerance. Like I mentioned earlier, the further you go away from the center to the intersection of the vehicle, if you're not within tolerance, it's going to start showing some kind of misalignment. And if you try to repair the vehicle with that inaccuracy, you might be damaging the car a little more than actually repairing it. Well, when you measure a vehicle, the first two measuring points that you generate in the center section is going to create what's known as your body zero line, the starting point for all length measurements. The total 4 control points is going to generate what's considered your center line, the starting point for all your width measurements, and the starting point for all your height measurements, known as your datum line.
So one thing I'll say there is, if you have a center base that's off, that doesn't mean you can't fix the car. It means you have to establish a good center base before you go any further with the repair of the vehicle. Before you start measuring out to the ends of the vehicle, you have to establish a good foundation. So once again, you have a bad foundation to start with, you can pull that foundation into place, get your targets in the right spot, but until you get the center section in the right spot and location, it's not going to matter, and it's not going to give you accurate readings out to the end of the rail. So you always want to establish a good base first and then measure out from there.
Exactly. And the thing is, when we measure a vehicle, what's the minimum amount of measuring points that we have to establish first? Well, that's going to be 8 control points, 4 in the center, and then 2 in the front and 2 in the rear. Same thing we used to do with self-centering gauges. It's the same thing we're still doing now with computerized measuring. Well, this also is going to help divide the vehicle into 3 separate sections, a front, center, and rear. The thing is, in a collision, each section can react independently from one another in a collision. So that's why it's important for us to measure all 3 sections, not just the point of impact.
Yes, I'll touch on that too. Cars are designed to absorb energy. So if it gets hit in the right front rail, it could travel all the way to the back of the car. So once again, establishing your 4 corner bases and then measuring out. It's a front end collision. You don't just measure the front, you measure the front and the rear. Like I said, the car is designed to absorb energy. So you're only cheating yourself if you don't check the back too, because if there's damage at the back from hitting the front, you have to look at it a little bit differently. And that's where the measuring system helps. It helps you determine if anything's correct. You can't do that with a tape measure. That's why 3-dimensional measuring is so important. You have to get all 3 dimensions, length, width, and height. That's very hard to do with a tape measure or a tram bar or any other system that you're using that doesn't take all dimensions, length, width, and height.
Yeah, like today's vehicles, they're engineered to collapse, absorb energy, and deflect. And the thing is, they don't just stay at the point of impact. They can travel to other sections of the vehicle. So if a vehicle did sustain indirect damage, well, by measuring the non-impact side, we'll discover that damage there. Because if we don't repair it or identify and then repair it, well, it can cause issues to other parts of the vehicle. Well, the same thing is, there's another reason why we're measuring on the non-impact side too, is to verify, hey, does this car have any prior damage, prior repairs? Did we set the vehicle up correctly? Is the vehicle leveled? Are we using the right control points? Are we using the right equipment? Do we select the right vehicle? So it's going to give us a lot of information to make sure that we're accurate with our measurements, because if we're not, well, we might cause some additional damage to the vehicle while we're trying to repair it.
Yep, and not only can we measure it, we can monitor it as we're doing the pulling. Make sure we're not over pulling or making sure we got everything correct.
Well, the thing is, if 8 is the minimal amount of measuring points you need to have on the vehicle, it's just to start the measuring process, well, what do you think the max is? Well, the max is until you discover no damage. So that can be your 8, it could be 12, it could be 26. The thing is, there is no limit of what the max amount of measuring points you're going to create to discover the extent of damage in the vehicle.
Yes, and I will add that on this system, it's not just about measuring the bottom of the car. You can measure anything on the car. As long as you can put a target on it, you can measure it. Whether you want to make side-to-side comparative measurements on the upper body, lower body, it doesn't just read the bottom of the car. I'm sure we'll talk about that a little more coming up here.
Yeah, so when we measure a vehicle, start from the point of impact, continue measuring to the center section until no damage is discovered. Well, that's going to help you in two ways. One, you're able to document the extent of damage the vehicle has so that you can create a better repair plan. You can figure out where you're going to anchor, hold, or create pivot points in the structure so that you can realign that damage. But it also, your documentation for your estimate. You want to make sure that you document everything that you find wrong with the vehicle, and on top of that, it uses information to determine, hey, is that structure part is it repairable? Can I section it, or do I need to do a whole new replacement of the assembly?
Yeah, and I will add on that the documentation. Documentation is great. It's something that you can keep in the folder, stay with the car. It's good if there's problems after the repair, going through the alignment. Usually when a car doesn't line up, the first thing alignment tech will say, oh, the frame is bent, and then you have that sheet showing that all your dimensions are correct. 9 times out of 10, if you did the measuring and did it right, usually the problem will be in the suspension part itself. Once again, having that documentation to show the next tech that has to work on it. One thing about mechanics techs, when they do an alignment, they're usually looking from the outside in, whereas a frame tech looks from the inside out. And like Ruben just said, if you're measuring everything and you keep measuring out to the point of where there's a problem. So if it's good up until this point, even at the control arm mountings, if that's all good, we know the parts, the problem is not in the vehicle itself. Aluminum parts nowadays, you can't see a bend on them. So if the control point where it connects is good, but it's still not lining up, clearly it's in a suspension part. But there's also ways to measure for those too now.
All right, now I'm going to talk about limitations of not using a three-dimensional computerized measuring system. Now, if you're going to use a point-to-point system, it's best to use it with some kind of reference guide so that you have a comparison of reference points to the vehicle. And if you have no guide, you have to use the vehicle's own symmetry. But the thing is, you're not going to get any height measurements when using a point-to-point measuring. So point-to-point measuring, you can use like a tram gauge, self-centering gauges, or a measuring tape. When using those systems, you're measuring 2 points, and you're doing that comparison. But it's best if you're going to use those that point-to-point system is to use it with some kind of reference guide, something that you can take. And all right, here's what the dimension of these 2 locations is going to be. Let me apply that to the vehicle and see, am I within that tolerance range? When using a point-to-point system, most of them want you to measure to the center of that hole or center of the bolt for more accuracy. So if you're using a tram gauge, make sure you have the correct pointer on there so it gives you the best centering on there. But one thing is, it doesn't give you any height reading. That's going to be the only problem with a point-to-point system. Now, if you don't have a measuring guide with you, well, the only thing you're able to measure is going to be length measurements and cross measurements, and you're comparing the right side to the left side of the vehicle. You're going to get absolutely nothing for height because there's no datum line that's been established throughout the vehicle structure.
I always looked at it as a tram bar for identifying a problem, not to solve the problem, but to identify it. You can use it. It's a quick reference. You use the tram bar, take it out, make your point, check your point to point, and if there's something wrong, that's when it needs to go on a 3D measuring system. Don't use your tram bar for your final repair. And
that goes to like the measuring heights. Like, no point-to-point system is going to give you actual dimension for a height, because to get a height, you need a datum plane. Datum plane is pretty much the starting point for all height measurements. Think of it being the number 0. It measures from somewhere below the vehicle upward to the structure. Well, you're not going to find that on a measuring printout. So there's going to be limitations on measuring height. So you might have to do just symmetry, measure from the frame down to your frame machine and compare left and right to see, am I within tolerance, or are they equal within symmetry, and does my sheet metal fit, and does the damage go away?
I started out, I've been in this business for quite a while now. Before we even had 3D measuring systems, and trust me, when the 3D measuring system first came out, I thought it was the best thing that came out ever. It sure solved a lot of problems. Once again, throwing those measurements on there, it only takes a few minutes, and you can monitor the car as you go. I think it's crazy if you don't use one.
Oh, it's very true. All right, next we're talking about measuring suspension components and mounted locations for a suspension analysis. So we're talking about measuring the front end, the rear end, pretty much doing a steering suspension check or alignment on the system, which don't get confused with wheel alignment. A wheel alignment is something different that's normally outside the shop area. But by doing your steering suspension alignment, you're going to get much more accurate and quicker wheel alignments. So when it comes to measuring a vehicle on the front hit, besides measuring your minimal 8 points, you also want to measure more points on the vehicle structure, especially your suspension, mounting points, and suspension locations. So on the front end, because once again, we can't see the extent of damage the structure can have, but we can measure parts like, example, the ball joints, the engine cradle, cross member, lower control arm, strut tower. It's going to help us identify if one, if the structures move, but two, if we have damage to any of these components. The thing is, we want to discover all the possible damage, so by the time we're done with the vehicle and it goes to the alignment, it's not getting rejected. We want to have successful alignments every single time. So by doing a steering and suspension check and alignment during the repair process of the vehicle, you're going to have a lot more successful wheel alignments. And the same thing for the rear, because we can't see the full extent of the damage the vehicle may have. So measuring your rear suspension components is going to give you, help you reduce any returns from the wheel alignment process. So measuring your rear suspension cradle, it's going to, you can see if you're having issues with a rear toe, or if a thrust angle exists, if you're set back, offset, or have a camber issue. Once again, it's not going to give you that specific OEM data, but it's going to give you a comparison between left and right if you have any kind of misalignment, so that you can address it.
Well, that's what I was saying before. That's the one thing nice about the Chief measuring system. You could put a target anywhere. So you can do a side-to-side comparison. Once you have a good base down the center line, everything's measured back to the center line. So if you think something's off on one side, you can do a comparative measure. Once again, see in the photo there, all you got to do is be able to hang a target on it, and you can take a measurement. So that's good for anything. It doesn't even have to be in the database. You could just compare it from one side to the other. Gives you a great idea if there's something wrong.
And the thing is, with any vehicle, if you most 3D computerized measuring systems may have special tools that you need to use that you can measure the strut tower. If you're able to measure the strut tower, great, you're going to have a great starting point, because think of the strut tower as a high pivot point in your suspension. They're all going to have the ability to measure the ball joints, a low pivot point suspension. So by measuring the strut tower or the ball joint, you're able to generate, pretty much think of like a steering axis line within the software. This is not an OEM spec, but a comparative measurement. So with the steering axis line, we can generate two steering geometries, SCI and caster. So if there's a width issue between the strut tower and the ball joint, well, that can affect my SCI and camber on that vehicle. If I have a length issue between those two components, well, I'm going to possibly have a caster problem with the vehicle. So this, once again, is going to help me do some diagnostics of the vehicle, so that I can resolve these issues before I take it to the alignment. And same thing with measuring with the rear. Measuring the rear suspension, the rear wheel hubs. If you have like a toe issue back there, well, it's going to discover that you have possible thrust angle misalignment, so that if it does, well, then you either fix the frame or replace the suspension component to correct the problem. And the thing is, a 3D computerized measuring system is not a wheel alignment system, but you can use it for your steering suspension check and alignment, because if the frame is put back to the correct location, well, now you measure the suspension components. If they're not symmetrical between left and right, well, that means it's damaged. So now you have an actual documentation that you have a damaged component, so you can replace it. Once they're all verified and replaced, now you can take the wheel alignment, and you're going to have a much higher success rate of those vehicles passing. No longer we're going to tell the customer, hey, the vehicle will be done at 4, realizing it didn't pass. Now we got to do further diagnostics and then put the vehicle back into the shop to get torn down and discover the damage. And you can also use it to measure ADAS sensors. Now, a lot of sensors on the vehicle are symmetrical, but some can be asymmetrical. So you got to understand what kind of sensor you're measuring. But most 3D computerized measuring software does have some kind of specification on location of some of these sensors, so they can use it to make sure that they're in the right spot. Like we mentioned before, some of these sensors can have a 0 to 1 millimeter of tolerance, so they have to be pretty exact to where they need to be so they can function properly.
Yeah, that's the part I like because once again, rear body panel hit is not unusual on a car. Those sensors are mounted to the back. If they're not pointed at the right angle, you're not going to pass that calibration. So once again, hanging a target on side to side and do a comparative measure, that's a great tool because when this first came out, we were repairing a lot of vehicles and then sending them for the calibration to find out that they could not calibrate them. And it was just a little tweak in the rear body panel, throwing the sensors off from one side to the other.
So by measuring your ADAS mounting locations and make sure the structure's put back in the right location, once again, you're going to have a lot more successful ADAS calibration. And that's all you want. You want less headaches at the very end of the repair process. And last thing is, we got to understand tolerances. Because the thing is, not every vehicle is built exactly like the OEM engineering diagram. So all computerized measure systems are a guide to help to restore the vehicle back to its correct dimensions. But sometimes a vehicle dimensions may vary beyond tolerances, but it can be good for that vehicle because that's just part of the way it came from the factory.
Yes, I've seen vehicles with 1 millimeter tolerances, and I've seen them with 7. So once again, that depends on the vehicle, but if you measure it and you're in spec, it's a great guide. Probably won't have any problems putting that car back together. I mean, we've all been there before the measuring systems came out where we put the grill in the last piece to find out it didn't fit because something was still wrong. So once again, I thought this was the best tool that ever came out when I was a structural tech. It really saved me a lot of time by setting it up. Doesn't take that long to set up, and it gives you accurate, good readings. So,
yeah. So when we repair a vehicle, we're using like an average tolerance. Usually a unibody has a 3 millimeter tolerance for the length, width, and height. A full frame has about a 5 millimeter tolerance for the length, width, and height. But we want to make sure that when we measure the center section, the tolerance is going to be a little bit less than that. Because if the closer you are to 0 in the center section, once again, the more accuracy you're going to have throughout the vehicle structure. And the thing is, there could be a lot of reasons why the vehicle may not match up to the specs. Example, the same jig they used to build the same car could get worn over time. Maybe they replaced one of the fixtures, so now it's slightly in a different location. Like I said, there's a lot of reasons. That's why your measuring system is a guide, because that car could just been built slightly different than the previous car.
yep, sometimes they're not built in the same location.
Yes, exactly. So using your computerized measure system, like I said, it's going to give you a lot of successful repairs. But once again, when you see some unusual numbers, you got to take the time to verify, is this indirect damage? Is they showing me prior damage, prior repairs? Is they showing me an incorrect setup? Did I select the wrong vehicle? So before you progress repairing the vehicle, you need to do troubleshooting and understand how your system works so that it's used properly. All right, there we go.
All right, that pretty much wraps it up. We went a little bit over our time here. But a lot of good information. Once again, I can't say more than enough how important it is to 3D measure. It will save you time. Everybody thinks it takes too long to set up the machine. It doesn't take that long, and it could save you a lot of time along the way.
Thank you, everyone.